So students, there are three ways to locate a point. The first way, the three prominent ways that we are discussing. So move, so these are xy coordinates. So move 2 units on x-axis, okay, 2 units. And then y is 3. So move 3 units along the y-axis. And you have reached your location. Let it be point A. So then this is origin O. So you can reach from here this way, A, let it be B. So O to B and B to A. Okay? And or you can directly reach from O to A also. Okay? So the first way was this is the first way how to locate a point, and the second way is now more mathematical way. So students, we write it as like A xy. We write the coordinates. Okay. Now we have A over here, and means instead of writing this way, I can further write it as the location of this point. So this distance is suppose r. Okay, so you can write it as vector form. In vector form, so this is the coordinate form. Second is the vector form. So how will you tell the location in the vector form? So vector r, this is the position vector. These were the position coordinates. So position coordinates, position vector. So this r is, I will ask you to move 2 units along this line. So first of all, what is a vector? And how do we write a vector mathematically? Vector is any physical quantity. Like here the physical quantity is distance that we are dealing with. So vector is any physical quantity that has magnitude plus direction. So here we are dealing with not distance, you can tell, because I am asking you to move in a specific direction. So this is sort of displacement, you can say. Distance in a particular direction is displacement. So vector has a magnitude and a direction. See, I am telling you move 2 units, but where? Is in this direction or this direction or this direction or this direction. I am telling you specific direction, move 2 units along the x-axis. Okay, so one way is move 2 units along x-axis, and then second, take left turn and move 3 units along y-axis. So this is how I will reach A. Now another way of writing it mathematically is that you write move 2 units along the x-axis. So how do we write it? So this 2 unit, if I take any general case, let it be x unit and y unit. So this will be x unit, suppose that you are moving. So I will be writing here x, so let it be small x. So x I cap. What does this mean? This I cap means move along the x-axis. So what is this I cap? And this is the way how do we write a vector. So whenever we write a vector, how do we write a vector mathematically? So vector equals to vector, of course. So this is what you need to understand. So vector is equals to magnitude multiplied by its direction with the help of unit vector. So this will tell you the direction. So magnitude multiply unit vector pointing in that direction in which your vector is. So that is how the way to write a vector. So always whenever you are writing a vector, vector equals to, and next thing is that vector equals to vector plus vector. Okay. So you can only add 2 vectors. So this is how you need to write vectors. So especially in this chapter, in all the chapters, everywhere in physics, okay, every time, all the times, you need to see this thing, that vector is equals to vector plus vector, or vector is equal to vector. Left hand side and right hand sides, unit will exactly be same. And you know, in scalars also, 6 centimeter is equals to 6 centimeter only. You cannot write 6 centimeter this side and 6 meters on this side. So units are, so this is, that's not equal. So that is why we tell the direction with this. So what is this? So this is also I cap. So we have two kind of vectors. One is we put arrow, and second is we put cap. So when we put arrow, so it can have any magnitude. But whenever we put this cap over a vector, so it means the magnitude is 1. So these vectors are where we put the cap. These vectors are unit vectors: I cap, J cap, K cap, or even A cap also, even R cap also. Wherever you are putting the cap, so these are unit vectors. Okay, so the dimension is means their magnitude is 1 unit. 1 unit, and that is why we call them unit vectors. So unit means magnitude 1. Next thing is that these vectors, what is the direction? Now you know the magnitude. What is the direction? So direction of I cap is along the x-axis. What direction of J cap is? It is along y-axis. 1 unit, move 1 unit along the x-axis, you get I cap. Now move 1 unit. So this is 1, 2, 3. So this is 1 unit J cap. Always remember, like this is vector R. So it means this vector, this line, this is telling you the magnitude. This is the magnitude of the vector, the length of this arrow, and this arrowhead, this tells you the direction. So that's how we represent a vector. Now here you can see that this is xi cap. So I cap is the vector this. What is xi cap? Xi cap is the vector from here to here. This is xi cap. Okay. If I write simply x, it's the length. Okay. Magnitude. Simply. Okay. X is magnitude. But when you are making a vector, so this vector from here to here is xi cap. Is this clear? So I cap multiply by the, okay. So so J cap is along the y direction, K cap is along the z direction. What is direction of A cap? So like here I have written this R. So how can I write it? I write it as R cap. So simple. Vector is equals to magnitude multiply its direction with unit vector. Okay. So R is equals to R. Suppose this is A vector. So its magnitude, how can we write the magnitude? So there are two ways of writing the magnitude of a vector. So magnitude of a vector, suppose vector R. So how do I write it? So there are two ways, either write simply R or put bar on both sides. So these are the two ways, first and second, to write the magnitude of the vector R. So how will I write A vector? So its magnitude, this magnitude is A, and multiply by the direction. And what is the direction? You can always write A cap. So here R cap. So but I cap, J cap and K cap are fixed for x, y, z. Otherwise, what is the direction of A cap? Direction of A vector. What is the direction of R cap? Vector R. So that's how we write. So A vector on this side, there is supposed to be vector on this side also. How can you, vector is equals to magnitude multiplied direction. What is the direction? A cap. So A cap. I hope this is clear. Now we were supposed to reach this point A. So xi cap, this vector, and now plus we need to move y units. So these are the coordinates, suppose x, y. So y units from this point, move y units y units. This is the magnitude. In which direction? In this. So instead of writing this whole, you can simply write xi cap. This is the same thing. And instead of writing this whole, you can simply write, so then take the means y j cap. So and means plus. So xi cap plus y. So you need not to write this thing. So that's the beauty of the physics, means you can write it mathematically. And then, so you can express yourself mathematically very well. Now this direction. So y units in which direction? So that's the direction. This is j cap, unit vector, telling you the direction. So not affecting the magnitude when you multiply with the unit vector, because the magnitude is 1. So that's how we write the position vector. So this is your position vector r. So this r, so either write it this way, r is equals to, and this is this. So vector is equals to vector plus vector. So what is the magnitude of this vector? I told you that the magnitude is small r. Yes. So r is the hypotenuse. So that is equals to under the root. This length is x. So x square, hypotenuse square is equals to base square plus perpendicular square. So simply you can write it. Now you can, this is theta, right? So how can you tell this direction? So tan theta is equals to, obviously, perpendicular upon base. So this is y. So y upon x. Another thing is, if you want to resolve these components, if this is theta, so write this base in terms of hypotenuse. So x is equals to r sine theta, and x is equals to r cos theta. Yes, resolving the components. What is x upon r? X is base upon hypotenuse, cos theta. So what is x equals to? R cos theta. What is y upon r equals to?
Sin theta.
Sin theta. So y is equals to r sin theta. So this is how we resolve the components. So students, these are all the basics that you need to know. Okay, now I think we can start a little bit of revision further, and then we can start. I hope you people are noting it down simultaneously along with me.
Yes, sir.
Okay. Now, students, let us move forward. Is there any doubt in it?
No, sir, what is the third way?
Okay, third way is like polar coordinates. You have studied in maths? Polar coordinates?
No, sir.
R theta? No? Polar coordinates, you have done the chapter. The third way is like r theta. Okay, how you will reach this point? So the third way is polar coordinates form. I think you have done the polar coordinate form. Like in short, you can write it as cis theta, and so, but in very short, you can reach here from here to here. This is the angle theta, right? So move r in the direction theta from the x-axis. Okay? So that's the third way, polar coordinates, right? How much length you are going to move? R. In which direction? Theta with the x-axis. Okay? So you can reach this point, isn't it?
Yes, sir.
Okay. Good. Okay. Any other doubt that you would like to ask? Okay. Now.
No, sir.
Okay. Good. Thank you. So now open your NCERT books. Page number 145. So page 145 NCERT. Now, the one way that we know is to write the coordinates of the, so we are studying coordinates, or means locate center of mass. And we have studied the coordinate form. So if there are these three masses, m1, m2 and m3, and this is my origin. So, and the coordinates of m1 is x1, y1, and the coordinate of m2 is x2, y2, and this is x3, y3. So what will the center of mass? Center of mass will be somewhere here, suppose. So the coordinates of the center of mass will be x. So let it be C, center of mass x, capital Y, capital Z. So capital X will be equals to m1. So you are writing x coordinate. So m1 and its x coordinate plus m2 and its x coordinate and plus m3 into its x coordinate and divided by the total sum, that is m1 plus m2 plus m3. Now what is y coordinate? So m1 and take the y coordinate of m1, and then m2 and take the y coordinate of m2, and then m3 and take the y coordinate of m3. So this is what the coordinates of center of mass is. Why do we need to study center of mass? Suppose I am applying force on a body. Till now we were assuming the bodies as point masses, point object, but now we will be considering them as their actual shape. Okay, so we call them extended body. So not as point mass, but we are their shape and size we are going to consider now, which is formed of number of particles, and it's a rigid body we are going to consider. So here whenever I am applying any force on this body, this is any force I am applying, external force. So this force is actually applied on the center of mass. Okay, this is applied on the center of mass. And so the acceleration, whose acceleration we are going to study? Of course, so F external is equals to m into a. So whose acceleration? Acceleration is of center of mass. So that is why we need to know what is the center of mass, and that is why it is so important to find the center of mass. So what is the location of center of mass? So that center of mass will move. Okay. So even I have given you one prominent example, like you have studied a case of projectile. So this a bomb is thrown, means is projected from the cannon, and suppose the bomb, it get exploded at this point into two fragments, suppose, or might be 2, 3, 4, 5. So if there are two fragments, so one will suppose move in this direction from here. So of course yes. One will fall over here, and this second one will fall over here. So these are the two masses, m1 and m2. What will be their location? So their location will be from, there are two ways to write the location. One way is, how much is this distance m1, this x1, and how much this distance x2. So the location simply will be x equals to m1 x1 plus m2 x2 divided by m1 plus m2, isn't it? So that was total mass m, that was equals to m1 plus m2. Any problems? No?
No, sir.
So that is my distance x. So students, but the center of mass will keep on moving. So if these are your particles are here, so their center of mass will be here. So the center of mass will keep on moving in the, so center of mass here, it is a virtual, there is no mass over here. So does the center of mass always lie on the body only? No. Here also, is this center of mass lie on any of the body? No. So center of mass doesn't always lie on the body. Even like you have a donut, suppose. So where is the center of mass of this? It is there at the center where it is empty. So center of mass can be on the object, can be outside, means does not lie on the object. So center of mass keep on moving in the same direction. Means why? The important thing is that here F external was 0. So center of mass can only accelerate when there is external force. And here this bomb is exploded due to internal force. So explosion was due to F internal forces. Okay. So that is why there was no impact, no acceleration, nothing of the. Of course, it is accelerating. The center of mass is accelerating. The external force acting on it is gravitational force, but the path of center of mass after the explosion is not changed because there is no new force. Okay, so this way also you have understood that how important it is to know the center of mass. So we will study today how to locate the center of mass.
Excuse me, sir.
Yes.
Means if we have internal